Linux is pretty good about detecting bad things. We saw previously that if you wanted to take a Linux program and compile it and have a stack buffer overflow, you had to turn off certain flags that are enabled by default in order to accomplish this. Similarly, there's a lot of protection that has been built into the heap handling. So why are we having so much trouble? Why is this so difficult? And really, this is a testament in many ways to the power of having an open source system. You have a system that literally developers around the world are working on constantly to improve, to make it more secure, to make it faster. Certainly, there are bugs that creep in along the way, but there are also things that get changed and fixed. And this is a great example where open source is really working for you. So in this case, here's the reality. If you do some research as to what's being used behind the scenes to allocate memory on the heap, what you'll find is that there are some system calls that can be made to allocate blocks of memory and deallocate blocks of memory. Now, these system calls are very expensive, and you don't want to call these functions every single time you want to allocate a couple of bytes of memory. In order to make this faster, Linux, just like Windows, allocates memory in chunks. So it keeps track of chunks itself in the malloc libraries that the operating system doesn't care about. Operating system allocates large chunks of memory, and that's it. They don't care about the small stuff. In previous attempts, we weren't able to effectively overflow this buffer, and our program wasn't going to die. We certainly couldn't have the free function call our shellcode. If you look into this, you'll see that older versions of Linux use something called dlmalloc, and the newer versions use something called ptmalloc. And there's been a lot of research done. And if you look back a year, there were a couple of edge cases where you could try to do something really tricky in order to successfully overflow a heap in Linux and have something bad happen when you call free. Nothing's 100%, but it's pretty close when it comes to this Linux implementation. So as a result, you're not very likely to get results you want by simply overflowing a buffer and then expecting the free function to call your shellcode. More likely that you'll get a SIG abort, such as what we have here. So what can you do? Well, I can successfully run my program, overflow my buffers, and to this, I will add data. So I'm going to rerun my program. Go ahead and continue. Right before my stir copy, I'll continue again. Now, what happens if I examine my memory? If I examine my memory, I see I have overflowed into buff2. Recall again that buff2 was at location 602040. So this, according to the programmer, is the second buffer. Here's why that's relevant. Depending on the program. Now, our program was very simple. We didn't do anything with the second buffer. We just allocated it and then we freed it. So when I call free, my program's going to crash. However, I could get lucky. If buff2 is using something that I can overwrite in such a way that I can control the flow of the program. For example, maybe there's a function pointer that's being used that's stored in a structure somewhere in buff2. If I can overwrite that and cause the program flow to change and the free is never reached, I can do something to exploit that problem, that flaw in this program. But unfortunately, this is not something that's easily searched for. We saw in the past where we could use things like grep. We could grep into a program and say, okay, are you calling stir copy? If you are, that's a problem. Are you calling printf with no format string? That's a problem. Fortunately, if you're a developer writing Linux programs, GCC will warn you, hey, this is not good. You shouldn't be doing this. So once again, there is some hope for you to find a problem with a Linux program that you might be able to exploit but it's a lot less likely and a lot more difficult to find these flaws than it is with Windows.